I released a new version of my Fisk AI harness and want to do a quick demonstration of two of the features. Previously, we've had a RAG system where you can ask systems questions over documentation. In this case, this is a set of open box documentation, Papa documentation, and it's the entire documentation about all of the types, all of the providers, all this kind of stuff. And I want to be able to ask how to use Puppet. And previously, it would show me citations at the end um, around where it got the information from because I'm grounding the questions in my knowledge base. But what I couldn't really do is a strong related entries because knowledge is inherently going to be done with look for the top 5 items, and that doesn't list you all other documentation that matches certain criteria, and there's not really a really good way to do that. And so in this release, I added a new tool here called Knowledge Enumerate, where it will find all of the documents that mentions these words together. And so using that capability, I made my query tool a little bit better here, so we can see it's telling me how to install the latest package, and it's citing its sources. These are the sources. This is the types MD, and where it's finding the information from. Um, and that's quite cool. And all of the different citations here. Previously, we couldn't answer things like all of the rest. Where else we can go look? Now with the enumerate function, I can find documentations what wasn't necessarily in the top 5 list, but that might still be relevant. And so, for instance, you can see there's a style guide mentioned over here, and it has 24 matches in the body, none in the title, so it's probably not that related. There is 20 title matches for some of the words we will search for, and 82 body matches, and so there's a high chance that it's a related document. And so using this, we're building out the related entries using that new feature. And so this required me to redesign a little bit how the full text search indexing works. But it doesn't require an LLM to build this, so it's not based on the vectors, it's based on the full text search. There's some tooling around this, CLI tooling, etc., that you can call, and so you can do Fisk rag match package, and these are all of the documents, and with the accounts that you saw in the thing, right? And we can also do words package, and this is the words, how it's doing the stemming and all that kind of stuff. That builds up the vocabulary in the document list search. Anyway, so that's the one feature. It's just a way to approach different kind of answers out of your corpus of documentation. I initially built this because I wanted to, for instance, I have scripts of a TV series, and I want to find all of the episodes where a certain character is part of the TV series or mentioned. And you can't really answer that from the top K kind of queries, but you can answer it from these kind of enumeration matches. But it's useful in other areas, as we've seen with this documentation. The other part, which you may have noticed if you were eagle-eyed, is that it supports OTel traces. And so if I go in here and I look at the most recent invocation, here is the agent run that you saw. And so it starts up, and in this case I've opted in, this is not on by default, the ability to see all of the prompt and all the tool inputs and outputs and stuff like this. And so here it goes, it talks to the LLM, and the LLM runs the tools. Here's the tool calls. That's how the LLM runs tool calls. And here's the tool calls around knowledge. This is we can see it went off for the top K. Retrieval, in this case, it's a local vector search, and so it's obviously it's quick. And it's also going to do embeddings against an LLM, so that would have been an LLM call in there. And then finally you can see all of the outputs and stuff. And so this gives you a full view into how your AI agent operates and what it's doing. And if I look for another one, for instance, here we are doing memory index, and that's against a JStream database. You'll remember the previous release introduced JStream based store for memory and for trace transactions, the transaction log. And here we can see memory list and what it ran and how long it took. And this is obviously a little bit slower than typical, because 82 milliseconds is not that fast. But that's because I had to reach out to a remote JStream server. In this case, I'm in Latvia, and the JStream server is, I believe, in Frankfurt. And so you can see the really good insights into what's happening within your agent infrastructure, which modules you're using, where the cost is lying, errors, typical runtimes, token use, all this kind of stuff. And this is more towards turning the libraries that I used to build Fisk AI into reusable libraries, where from Go you can build your own agent. If I were to look, let's have a look here as an example, for instance. I create a config, I set up my LLM stuff, I create my agent with its system prompt, etc. And I run it, and that's it. This would be from Go. You've created a LLM agent that does the same work as the one on the CLI. And so towards allowing me to build a platform for hosting LLM agents, this allows me to view into that running platform, how many of them are suspended, how many I'm running, how long it takes, all this kind of stuff. And so this was quite a large chunk of work. Obviously, this is code written by Claude, but the OTel libraries is frankly horrific. But the outcome is really nice, and what I really like is that there is actually a standard called the GenAI conventions, that once you implement those conventions, and you see them over here, these are basically tags, right? Compatible tools, like here I'm using telemetry.dev, they have a great free tier. And telemetry.dev understands the GenAI format, and so when I emit a agent start or a chat parameters, it understands that these are what it means to an LLM agent. And so this is a specific LLM agent observability platform, and you can manage your costs and all this kind of stuff. There you can see. So those are the two major features that landed in 004. I was really keen to see how the OTel stuff really works, and in these AI agents. And other than that, the RAG work, I had started down the path of building a graph database, but ultimately in the end, the graph database wasn't going to do what I needed to do for my use case. We may come back to it. But for now, the enumeration is already a big win. That's it for now. Thank you very much for your time.